Welcome to CS1101. Each lecture in this class will be broken into 3 parts. So in the case of lecture 1, it'll be lecture 1.1, 1.2, and 1.3. This is for ease of recording as well as ease of consuming, so there's a natural breaking point for you to take a break. With no further ado, let's jump into part 1. So my name is Jesse Roberts. I will not be having any office hours on campus. Obviously, that wouldn't be helpful anyway. This is an online asynchronous course. To set up an appointment with me to meet, simply email me. We'll get into how to set up office hours with the TAs a little bit later in the lecture. But for myself to set up a time to meet, email me directly and propose a time that would work well for you. And typically Zoom meetings will be scheduled for same day, if possible or realistic for myself, and if not, for the following weekday. So don't count on a same day meeting. Expect that it will be a next weekday meeting. So if you need help on a Friday, ask on Thursday. So a little bit about me. My background is in electrical engineering and computer science. I study in computer science, artificial intelligence, computational creativity specifically. My professional background, I spent 6 years working in industry, primarily as an industrial automation programmer for industrial robotics. So actually, a lot of that is applicable here, as some of the most cutting-edge industrial robotics are programmed in Java. So I wrote a lot of Java for controlling and implementing systems in human collaborative robots. If any of that is interesting to you, feel free to email me. I'm glad to talk about it anytime. So we have 2 TAs for the course. They are listed on Brightspace, their names and their email addresses. So obviously feel free to reach out to them via email. Their office hours are going to be set up via a system called Calendly. Now, to access the booking for office hours, you go to the website, go to Brightspace, and on the navigation bar, there is an item that says Schedule Meeting. You click that and it'll take you to the meeting scheduler, and you select your time and day. So if you want to set up a TA meeting, that's the appropriate way to go about that. You can email them directly, but the TA you email may or may not have office hours that day. This is a little more general and is more likely that you'll get fast help. So email is fine, but it may be slow. This should be faster. Obviously, that's not how to set up a meeting with me, as I mentioned before. Email me directly to set up a meeting with myself. So, in addition to the option to schedule a Zoom meeting to get any additional help that you need, item 1 down here says that each student is to correspond with their assigned TA via email twice weekly. We'll discuss more about that later, but it is exactly what it sounds like. You are required to email the TA that's been assigned to you as your corresponding TA twice per week, and the content of that email should be any reflection on the course material that you've gone over and any questions that you may have. The reasoning here is ordinarily there would be an in-class portion of a course, and after class was over, after the lecture was over, there would be an opportunity to talk with the professor, and that obviously doesn't exist here. So I want to create an open dialogue with each of you and your assigned TA. The book for the course is not available via the bookstore because we are using an online book through a company called Zybooks. So to access the Zybook, you create an account at learn.zybooks.com, and you enter this zybook code, and that's how you gain access to the book for this semester. There is a subscription cost, which is comparable to a textbook. So you need to make sure that you immediately today are registered on zyBooks. Use your Brightspace official name, so not any sort of abbreviation or nickname. It needs to match your name on Brightspace. You can include any informal name that you want to use in parentheses, and ensure that your student ID is your ViewNet ID. So make sure that you get those matching correctly, because that's how we will know whose grade goes where. And that access will continue through the first part of July. So you'll still have access to go over the material if you would like shortly after the course ends. As a supplemental resource, I recommend you getting the book Building Java Programs. You don't have to get the 5th edition. It says 5th edition, but any of the previous editions will do. 4th edition, I think there's probably some free versions out there. I don't know. I know that it's available at this link for around $40. It's also available via the bookstore. It's a good reference material for supplementing what we talk about in lecture, and will really be helpful if you're a CS major and are going to be moving forward. It's good to have a reference for a language that you've gone through to be able to look back at and to be able to use if you ever need it again, and it's not unfamiliar. You're not having to look through a new book that you found online to find the references you need and something you're familiar with that you've used before. It's very good, very helpful. There's a lot of good exercises built into it, into the reading, and there will be assigned reading to accompany each lecture. Obviously, that's not graded. You don't have to do that. However, I would recommend that you do for your own understanding and for success in the course. So the catalog description says that this is an intensive introduction to algorithm development and problem solving on the computer, and goes on. Intensive is the word to describe the normal semester version of this course. This is a very fast-paced and intensive course, so just be aware of that and make sure you stay on top of things. To make that a little bit easier, there are multiple calendars available on Brightspace. Again, on the navigation bar, course calendars. If you click that, there's an overarching course calendar. There's also a due dates calendar. So if you wonder, is anything due today, you can go to the due dates calendar and look, and you'll know what is due for this day. Hopefully you're not waiting till the day that it's due to start. That's going to cause problems for yourself. But what you will learn in this course in general, so you're going to get an introduction to programming, specifically using the Java programming language. But the things you're going to learn in this course transcend any particular language. So though you will be learning the specifics of the Java language, you're going to be learning things in general about programming, which will be applicable to C++, embedded C, ladder logic, any language out there. This will be applicable to. And then, moreover, you're going to be getting an introduction to computer science. So the ideas of algorithm design analysis, problem solving in general with computers, decomposition of problems to be able to apply a computer efficiently to the problem, and then terminology to be able to talk about those sort of things and discuss it in a meaningful way. And then there's something that we refer to as object-oriented programming and object-oriented philosophy to programming, which is very important in modern programming. This will be a short introduction to it toward the end of the course. And then the ideas of program correctness, testing, and error checking. So as far as course administration, Brightspace is the primary source for all information about the course. You need to check it daily, probably multiple times a day for your own benefit. Not that content will be posted multiple times a day. Any content for the day will be posted in the morning and it will be available throughout the day, obviously, and from that point on. But I would check it daily. What you'll find on there: lectures, announcements, the syllabus, assignment calendar, the due date calendar. Your programming assignments are, as far as any grades are listed there, but your programming assignments will actually be done through Zybooks. And then any and all course resources and references will be on Brightspace as well. So Brightspace is very, very important. Make sure you're on there today and you have familiarized yourself with the layout and how to schedule a meeting with the TA, how to access the calendars and view what is due and what you should be working on. Make sure that you're familiar with the platform. We're going to use email a lot. That's probably not different from any other course you've been in. However, being that this is a distance course, we're going to rely on it more heavily. So, as I mentioned, bi-weekly TA correspondence. So, each week on Monday and Wednesday, you're expected to email the assigned TA. So, there will be a TA assigned to you to correspond with. You're to email that TA, and you are to reflect on the material that you've covered, and you are to ask any questions that you may have. That's a very important thing that I want to make sure that you all do. It is part of your grade. It's 5% of your grade. There should be 8 emails, 1 the first week, 2 for the next 3 weeks, and then 1 the last week. So I want to make sure that that's something you do, so it's part of the grade. It's 5% of your grade. Email is also used for, as I mentioned, requesting a Zoom meeting with myself, and any correspondence you need to have with myself. So utilize emails. I'm more than happy to discuss with you via email, more than happy to set up a time to meet with each of you. I want to see that each of you succeeds in this course and comes away understanding how to program, move forward in CS, if that's your path, or if this is just a course you wanted to take. Either way, look forward to meeting and talking with you via email and Zoom. A couple of notes on email. First of all, make sure you include CS1101 and your name in the email for a couple of reasons. First of all, if it's a TA correspondence email, then they're going to need to be able to officially look back, see who's emailed them, and then place your grade in Brightspace. As far as the grade goes, it's pass, fail. You either did it or you didn't. And did it or didn't means did or did not send an email which reflected on the material and asked I'm not requiring that you ask questions, but at minimum you have to reflect on the material. So you can't just say, hey, how are you? And that's it. You need to say something meaningful as a reflection on the material. So assuming that you've sent that email, you get a 100 for that particular email. But yes, be sure to include CS1101, and then I would say dash your name, because that's how they're going to know who emailed them and where to put the grade. That's also how I'll know that I need to pay attention to the email and not ignore it. So make sure you do that. Check your email daily. So we will also periodically send out emails, and that could be for various reasons, but at any point you're expected to be responsible for checking and being aware of any emails that we send to you. So Zoom as a platform, hopefully you're familiar with it by now. I think everyone is at this point due to the pandemic. However, if you're not, download it, make sure you have it. That's what you're going to use to meet with TAs or myself if you need one-on-one instruction or support. I mentioned it before, but just making sure that everyone is on the same page. Use the link in the Brightspace navigation bar to set up a Zoom meeting with a TA. That's your first stop shop for getting help. You can certainly email myself and I'll try to set up a time to meet with you for the following weekday, but that's going to be slow and this is faster. So familiarize yourself with that, make sure you know how that works, where it's at. Zoom meetings will be held on weekdays. So first of all, there's no assignments or activities due on the weekend, and that was intentional because I'm not going to have any office hours held by the TAs or myself on the weekends. So Office hours via Zoom meeting will be held on weekdays. So if you request a Zoom meeting at 2 o'clock on Friday, you're probably not going to get one until sometime on Monday. So just be aware of that. We're going to try to keep this in working hours, in business hours. So plan for that, and plan to try to schedule Zoom meetings as soon as you realize you need help. Don't wait till the last minute to get started on your assignments, and don't wait till the last minute to ask for help, because there's a good chance that other people are going to be asking for help as well, and there's a limited amount of availability each day. And there's not much we can do about that. That's true even if we were in office hours in for a regular class. So plan ahead, and office hours are going to be allocated on a first come, first served basis. Now, don't snatch up all the office hours. You could go into the platform and reserve every day for this semester. Obviously, if you do that, I'm going to delete all your calendar entries, and I'm going to think you're just spam, and I'm going to block you from the site. So don't do that. You schedule them as you need them, but understand that they are scheduled first come, first serve. If for any reason there's a problem with the meeting scheduler, if you use the link and it says this link is broken, or you go there and there are no availability for the next 5 days, then please email me. This is the first time I've used this scheduling system, and I think it's very streamlined, and it seems very simple to use, and it works well in my testing. However, it could break, and if it breaks, obviously I want you all to get the help that you need. So please, if it is broken, notify me immediately, and I will get it fixed. Again, don't try to schedule a Zoom meeting with myself, the instructor, via the scheduling link on Brightspace. Email me directly to request a Zoom meeting, and I'm more than happy to meet with you. Like I said, likely the meeting will be scheduled for the following weekday. There are 2 tests in this course. There's a midterm, which actually shows up in week 2, so that's kind of early for midterm, but it's only a 4-week course. So midterm will be week 2, and then there will be a final in the last week of the course on July 3rd. So we will grade the exams on Gradescope, and they will be delivered to you via Gradescope, and you'll have the opportunity to look over your exam. I'm not 100% certain yet how exams are going to be taken. I believe that I will have them be open book, and they'll probably be open book. They'll probably be something that you have to use your own notebook paper to respond to, and then you either scan or take pictures of and submit via Brightspace. However, I haven't solidified that yet. I'll get back to you on it. However, Gradescope will be the way that I return tests to you, but there's no action needed from you there, because I will add you to Gradescope when that is necessary. IntelliJ is a IDE, so it's integrated development environment for Java. This is what you'll use for typing in and running your Java programs for the class. And it's platform independent, more or less. I'm pretty sure there's a Ubuntu Linux version, a Windows version, and a Mac version. I know for certain there's a Windows and a Mac version. This isn't very helpful to you. It is also available on the Feathering Hill lab computers. However, I'm not certain if any of you have access to them. If you do, then you're more than welcome to use those. It is free. The instructions for downloading and installing it are on Brightspace, so please do that. It's not necessary that you have that done today, but do that within the next 2 days. So by Wednesday this week, you need to have IntelliJ installed on your computer. We will go over how to use it in a further lecture. So the way that we're going to carry this course out in general, there will be 3 lectures each week. Obviously, each of those lectures will have a part 1, 2, and 3, just as this will. So each week on Monday, Tuesday, and Wednesday, there will be a lecture released. Each lecture will be approximately 3 hours. You're responsible for all material covered in the videos, as well as all material in the assigned reading. The course workload, then, is going to be based off of an approximation that for every for every hour of lecture, there should be approximately 2 to 3 hours of student independent work. So that puts you, so given that this is a 10-hour a week course, that puts us at 20 to 30 hours worth of work per week that you will do outside of watching lectures. Sounds like a lot because it is a lot. We're doing a semester's worth of work in 1 month. So part of the weekly workload will be what are referred to as ZYs, Z-Y-S. Those are Zybook learning activities. So there will be 3 of those each week, one assigned Monday, Tuesday, and Wednesday in conjunction with the lecture. And those will probably take you between 3 to 9 hours a week. There will be programming assignments. This is the most important component of the course. Completing the programming assignments is paramount. If you fail to turn in a Xi, well, that's okay. You get 3 free Xis. So your 3 lowest Xi book activities will be dropped. No programming assignments will be dropped. Programming assignments are what this course is all about. You're here to learn how to program, and programming assignments is how you'll learn how to program. So you're going to spend between 9 and 20 hours a week programming. Some of these are easy, some of them are not. These are referred to as PAs, and they're in Xi Labs, so that's also a part of the Xibooks platform. TA correspondence, that shouldn't take you more than 30 minutes a week. It's not a guessing game, it's not anything hard. Just think back about what you've read, what you've learned, and respond to it and ask any questions. Again, it's just a way to create open dialogue with you and the course staff. Then obviously exams. There will be one exam midterm, and one exam final. So how do those play into your grade? Well, the TA email correspondence is 5% of your grade. So 8 emails, you email 8 times throughout this month, twice a week, and you get 5% of your grade. Programming assignments are 50% of your grade because those are the most important thing, as I mentioned before. If you can't learn how to program without programming a good bit. So 50% of your grade is the programming assignments. Now there's several. There's 11 programming assignments, and each one has between 1 and 3 components to it. So this is split across many programming assignments. Keep up with those, get them done, and have them turned in on time. You'll have 1 week to do each of them, but there will be multiple ones assigned each week. 3, actually. 3, in fact. Zybook activities. That counts as 1 exam grade, 15% of your grade. Exam 1, 15% of your grade. The final, 15% of your grade. It's a simple grading structure, which puts the emphasis on the programming assignments. So letter grades are assigned in the usual fashion: 90 above is an A, 80 to 89 a B, so forth. Cutoffs for pluses are going to be determined after the semester, after the final exams. So those will not be determined at this point. But we'll use the gapping method. So a little bit more about the Zybook activities. As I said, there'll be 3 a week. 1 assigned Monday, 1 assigned Tuesday, and 1 assigned Wednesday. Now, the structure for when those are due is very simple. Mondays is due Wednesday, Tuesdays is due Thursday, Wednesdays is due Friday. So for each one, you will have 2 days. 2 days to complete. So Monday is due Wednesday, Tuesday is due Thursday, and Wednesdays is due Friday. You don't have any Zybooks due on the weekends. As I said, nothing's due on the weekend. So these are similar to reading through a textbook, but more interactive. No Zybook activities are going to be allowed to be turned in late. There is a due date for each of those, and if you don't get it done by the due date, then you get a 0. Don't worry too much about that if it's your first time or second time for that happening. Obviously, if that were the first 2, that would be bad. But you get three drops. And that applies to the Xyz only. So you don't get to drop any of the PAs, but you get to drop 3 Zybook activities. So be sparing with that. That's all you have. 4 won't be dropped. To get 100 on each of the Zybook activities, you need to complete 90 or greater percent. So if you get to 89% complete, you get an 89. However, if you go 1% more, you get 100. So just make sure that you complete all the Zybook activities to 90%, and you'll get 100 on all of them. That should be easy points. They're there to reinforce the material, to introduce material, and to make sure that you have learned the concepts. And I think the Zybook method and that platform is much better than a traditional quizzing environment. So I think you'll like it. I think it'll be a good experience, and it's going to be used further if you're continuing on in CS. So you should get familiar with it now. There will also be 3 weekly programming assignments. So 3 Zybook activities assigned each week, 3 programming assignments each week. Programming assignments are also assigned Monday, Tuesday, and Wednesday. They are due the following Monday, Tuesday, and Wednesday. So you get 1 week per assignment. So there will be 1 assigned on Monday, 1 assigned on Tuesday, 1 assigned on Wednesday, and it's due the following Monday, Tuesday, and Wednesday. Get started on these early. You should be, if we said that there's 10 hours of lectures and potentially 30 hours of outside lecture work per week, that means this is a full-time job. 40 hours a week is not an unrealistic expectation for the amount of work you're going to have to put into this course. Therefore, you need to work diligently each day on the programming assignments and the Zybook activities. And when you realize that there's an issue, when you realize you don't understand something or you need help, go for help immediately. Don't wait, because once you get to the deadline and you're trying to get help, you may not get help before it's time to turn it in, and that's really on you. There's no defense for it, and there's nothing we can do about it. The programming assignments are pre-graded. So as soon as you submit it on the Zybook, in the Zybook platform, it will grade it for you and tell you what your grade is. Now, your grade may go down when it gets put into Brightspace, because we will look over it, and let's say that you used none of the appropriate style, and you clearly had done things in a way in which the assignment requested that you not, but it was functional, then your grade is going to go down. Obviously, other ways for your grade to go down would be cheating. Don't do that. There are tools built into the Zybook platform that do comparison checking, and they're quite sophisticated. So don't expect that you're going to get away with that. More on that later. The turnaround for grading those and those grades being posted to Brightspace is 7 days, typically. So we'll try to stick to that schedule. One helpful component built into the course is 4 free late days for use only on programming assignments. So Zybooks, you get to drop 3, and programming assignments, you get 4 free late days. You're only allowed to use a maximum of 2 on any one assignment. So let's say that Monday comes around and you have been working really hard, but you still haven't got it. You haven't got it figured out, and you haven't scheduled a meeting with the TA. You schedule a meeting, but the TA says, I can't meet today. I have to meet tomorrow. Okay, well, you can use a free late day. You can meet with the TA, finish the assignment, and turn in the next day, and there will be no penalty. Now, like I said, you only get 4 of those, and a maximum of 2 can be applied to any one assignment. So use them wisely, and I would say probably save them for the harder assignments that will come later in the semester. And you may not use them on the Zybook activities. As I pointed out before, no late Zybook activities will be accepted. It will be a 0. However, you get 3 drops. And no PAs will be accepted after 48 hours. That's because no more than 2 free late days may be used on a single PA. So as far as some tentative exam dates, the first exam is intended for June 11th, so next Thursday. It will be open book. It will cover everything that we have covered up to that point. The final exam is on July 3rd. Typically, finals are 3 hours long. I'm not certain that this one will be, but it may be up to 3 hours long. There will be no alternate exam dates. And as far as the makeup policy, the makeup policy is fairly harsh. Makeup exams are for serious documented reasons only. So what a serious documented reason would be is not that you went to a clinic and got a card saying that you were at the doctor's office. Since this is an online course, I really don't see any reason why you wouldn't be able to take the exam the day that it was required. So I don't foresee this being an issue. But to be able to excuse an exam that you've missed, you would really need to contact the Dean of Students office and get them to validate that you indeed could not attend the exam. Otherwise, a 50% penalty is going to be assessed on any unexcused late exam. So take that seriously. Take your exams on time. That's all there is to say about that. Very important. Do your own work. So on Brightspace, there is an academic policy. All right, an academic conduct policy, referred to here as academic honesty policy. Be aware of what it says. You're responsible to abide by that policy. Do not look at, share, or copy any code in any form with any student or website at any point. So, a couple of examples here. Let's say someone emails you and says, hey, I need help. Did you figure out how to do X? Giving them any help at all makes both of you in violation of the academic conduct policy. All right? So we will be able to tell if there are significant similarities in your code. Changing variable names will not fool the tool. It will not fool the system that we use to detect similarities. So changing small structural differences or adding in small structural differences will not be able to mask that you've copied from someone else's code. So if you're caught cheating, you will be reported to the Honor Council, and the minimum punishment is failure of the course. So make sure that you take this seriously. There's no need that anyone fail for cheating. However, it seems to happen every year. So the maximum penalty here is suspension from the university in general, the minimum being failure in the course. Don't give help, don't receive help. The point of programming in this class is not to have a working program. It's to learn how to program. You do that by struggling through and figuring out how to make it work. The TAs and myself are here to support you in any way to be able to make that happen. And we will give all the help that is appropriate to support you in learning how to program. But getting help from others is not part of that. So Don't ask and don't give help. So this is a restatement of what I've said already. The homework assignments are building knowledge through practice. That's what I was saying about this course is about learning to program through programming itself. So a working program is not the goal. The goal is that each of you will have to struggle through and learn how to create, yes, a program that works, but a program that is maintainable and documented. And struggling through that yourself is how you become good at it. So what is this course really all about? It's about writing programs and learning to think logically. We, as computer scientists, design programs, evaluate them, fix them, and improve them. Fix and improve sound like synonyms there, but understand designing programs is about creating a novel program. Evaluating a program is how to understand its fundamental characteristics. How much time will it take for that program to execute relative to the number of inputs? How much space will it take to execute? Fixing them is about rectifying fundamental errors in the code that prevent it from working at all. Improving a program is a little different, and an improvement to a program typically would be something that made it run in less time. So if you were able to, if you were able to sort every book in existence in less time than a previous algorithm, that would be an improvement. So specifically, what are you going to learn in this course? First, you're going to learn how to analyze a problem and be able to apply computing principles, and as well as other disciplines, so that when you have analyzed the problem, you can design, implement, and evaluate a computing solution. And you're going to apply computer science theory to be able to perform the necessary software development to generate this solution, this computing-based solution. Putting it in a little more simplistic terms, you're going to learn how to look at a problem and decompose it into its fundamental pieces, how to come up with a program that meets a certain set of requirements and that solves the original problem that was identified. And you're going to learn how to do that using standard software development fundamentals. So Java is the language we will be using for this class. You may or may not be aware of exactly what a programming language is, but just as we need a language to communicate with each other in, English obviously, we need a language to communicate with the computer. Why can't we use English? Well, English is, fairly imprecise. If I were giving instructions for how to make bread and I said, mix the dry ingredients is actually somewhat ambiguous. Every dry ingredient I have in my kitchen, every dry ingredient I have on my counter, what? So you need a language which is more precise, and the native language to a computer is ones and zeros, quite literally. So in a computer there are memory locations, and each memory location, at each fundamental location, there is a Boolean value of 1 or 0, a bit. Well, trying to code directly in bits, ones and zeros, will drive you insane. Even though some fairly impressive programming feats have been done programming directly in ones and zeros, it's much more realistic to program in a language like Java, which is currently the #1 language. It's common to start with Java as a first programming language, mostly because it's high level and it's not so tedious as trying to program in assembly. A little less tedious than trying to program in C or C++, though it does not have the low-level control of C or C++. There are other things to know about Java as sort of a caveat. This is an industrial strength language. Like I said, I used it to program industrial robotics in human collaborative environments. that comes with advantages and disadvantages for learning. It's supported by a lot of libraries, which is beneficial and helpful, so that you don't have to reinvent the wheel for every individual task. However, it's intended for coding million-line programs. So, it's appropriate to start out learning to drive a vehicle by driving a tricycle, probably, rather than starting on a car or something like that. In this case, as far as programming languages go, in that tricycle car analogy, you're learning to drive a fighter jet. It's a powerful, modern, cutting-edge language. So understand that is going to be somewhat difficult, but it is better than learning a toy language, because what you learn in this course is going to be immediately applicable to other programming languages, but also it's very possible that if you continue in computer science and you go on to be a computer science professional, it's very possible that you will program on a day-to-day basis in Java. CS1101 is the first course in computer science that many people take. So at that point, it's a good time to ask the question and discuss, in general, what is computer science? Well, it's not 100% about computers. There's a quote I like here. Computer science is no more about computers than astronomy is about telescopes. That's true, because the study of computer science was invented before there were computers. Computers were a product of computer science. But what is computer science? Well, as some facets to it, in general, creative problem solving, logical thinking, and precise instructions. That's the view of computer science we're going to take and focus on for this course. And it's very relevant in today's world, because though 20 years ago computers were still attempting to penetrate into a lot of markets and everyday workplaces, today that has taken place, and most things in our modern world are run or connected to systems that run on computers. And inside computer science, there are many sub-disciplines. So specifically, the study of graphics and robotics, you may not immediately think of those as computer science, but they are. So modern robotics is all about developing a multi-axis system to be able to manipulate the environment in an intelligent way. Well, when you start trying to infuse intelligence into a machine, you're talking about a computer. So robotics, unless you just want it to be a remote controlled system, even then arguably it may be computer science. Unless you just want it to be a remote controlled system, robotics is computer science. Computational biology. Computational biology has rendered new algorithms into computer science, such as protein folding, those sort of things. So computational biology would be a sub-discipline of computer science. Artificial intelligence, the study of programming languages in general, data processing, HCI, human-computer interaction. Trying to figure out better and better ways for a person to interact with a computer via their eyes, or perhaps voice interaction, or even there are people who are working with trying to do a direct human brain computer interaction. So all those would be considered sub-disciplines of computer science. So here are some common myths that you'll run into regarding computer science majors who become, in the future, computer science professionals. You tend to spend your life in a soulless office, or perhaps in your parents' basement writing code. That's a good one. Computer science is only about nitpicky details. That almost feels a little true. Computer science requires a lot of precision. It requires being able to tell a computer precisely exactly what to do, and it perform a task that you want it to perform, and that only happens if you're very precise. So That might be somewhat accurate. CS is not creative. That's completely false. Computer science is a science, but it's almost more art when you get into a lot of complicated code. Um, Computer science is only for people who want to work at large software companies. That's definitely not true. I have friends who work for startup companies, who work for local mom and pop companies. Um, there are many different jobs available in computer science. And then lastly, there's sort of a common myth that thinks that all computer science jobs have been outsourced and sent overseas. That's not accurate either. So let's look at what is accurate about the job prospects for a computer science major. So first of all, the pie chart on the left shows all STEM jobs through 2020, new STEM jobs, so developed STEM jobs through 2020. 73% of all those are computing-based jobs. So there's also 16% engineering, which is a fair amount, but overwhelmingly, Pac-Man here is computer science. Within that, we have a few computing researchers, so that would be people who have recently graduated with PhDs, things like that, going out to be researchers. Systems analysts. Systems analysts are people who oversee large sections of computer infrastructure. So Dennis Nedry in Jurassic Park, if you remember in the original Jurassic Park film, Dennis Nedry would have been a systems analyst. Software developer. Software developers get to do the fun thing, right? They generate new software. So you work for Apple or Microsoft or whichever company, even on down to small companies, and develop apps or software for PCs and such to solve everyday problems for the company or for the public in general. Computing support, IT support systems, IT support personnel. Database administrator. So database administrators are becoming a central role in nearly every company as data tracking becomes more and more important. So, not that long ago, there was the big problem with the Takata airbags where some of them started exploding in cars due to degradation of materials in the airbag inflators. Well, there was a large recall. Millions of cars had to be recalled, and the reason was because Takata didn't have proper database infrastructure, and they didn't have a database administrator. So it's becoming more and more common that every company keeps track of all their data to prevent things like Takata. Network system administrator, similar to a system analyst in some ways. They, again, oversee areas of computer infrastructure, but specifically they would be a person who oversees the computer network. So if for some reason your switch crashes and you lose internet connectivity for the entire dorm, the person who's going to respond is going to be the network system administrator. Info security, or web developer, network architect, those positions are not synonymous, but they are related. Information security officer, that's going to be someone who's in charge of making sure that systems are designed appropriately to ensure the integrity of users' information. Web developer is going to be designing web applications that you use every day. Network architect, similar to a network system administrator, the network architect is going to help new companies to lay out and design an appropriate network scheme to be able to support the level of traffic and the necessary level of redundancy, and then miscellaneous. So within the computing job options, it's pretty varied. You have those who are generating new software developers, web developers, network architects, computing researchers. Then you have those people who are engaged in the upkeep and the administration of existing systems. And as we become more and more reliant on computing solutions to everyday problems, these numbers only increase. So the computing job market is a growth job market. So that's the reality. It's very good job prospects. And let's take a further look at that. So for STEM jobs through 2020 versus college grads, with the number of grads being represented by the orange bar and the number of jobs represented by the yellow bar, if you notice, in engineering, physical sciences, life sciences, and mathematics, there are always more grads than there are jobs. That's going to be a problem for someone who is looking for a job in those fields. I'm not saying that if you're in engineering you won't find a job. Most do, but somebody doesn't, because there are more grads than jobs. However, in computing, there is more demand than there are people to fill it. There's more jobs than there are graduates, which means that there is no reason whatsoever that a person with a computer science degree would go unemployed. So your job prospects are great if you are a computer science grad. So there's some information published regarding this that showed that the three best majors for your career to ensure longevity and success in a career currently, number 1 is computer science, number 2 is management information systems, and 3 is software engineering. So the top 3 best majors to support a career are computer science or computer science adjacent jobs. All 3 of these would be considered computer science. Then, the rest of the list continues from there, being finance, economics, biomedical engineering, business, and math. But it's telling that the top 3 jobs are computer science jobs, computer science majors. So the National Association of Colleges and Employers released a statement saying that bachelor degree graduates with in the STEM disciplines receive the highest average starting salaries. Specifically, those in computer science were the highest paid, with the starting salary average being $71,000. For a research scientist, that starting salary is $114,000. Well, it's the median annual wage for a research scientist anyway. The second best starting salary behind computer science was general engineering, for $66,000. So not a bad step behind. And the next would be mathematics and statistics with $62,000. Looking specifically at Vanderbilt, the average starting salary for a computer science grad from Vanderbilt is just north of $100,000, with the median being just north of that as well. That's the highest for any of the engineering schools, and with the overall being about average for the engineering majors. So computer science is a promising and lucrative field. But then why are you in this class? Don't be in it for the wrong reasons. Okay? Good reasons to be in this class would be that you're a person that enjoys creative thinking, problem solving, and puzzles. If you want to learn skills that will guaranteed help you in your career, this is a class to be in. I knew a music therapist that wound up being a assistant director at a university for their honors program, and he used computing to make his life a lot easier and generated a lot of solutions for everyday minutia. Helped him in his job and made him look like he was getting more done than he had been previously able to do, because he was really leveraging computers to improve his function in that position. So this is generally applicable. It'll help you learn skills that will help you in your career. If you want to learn the basics of computer programming, which is, again, applicable in almost all fields, and definitely applicable if you want to continue through computer science, this is the course for you. And in general, computers are likely to play a major role in solving most of the upcoming major problems in the world: climate change, hunger, disease. Likely, computers and computing solutions will play a major role in dealing with those problems. To be able to be an active member of those solutions, an active participant in those solutions, you need to know something about computers, and this is a great place to start. So regardless of why you're in this course, be open to the possibility that this course is likely going to change your perspective. Software has changed everything. Science, engineering, social sciences, all these disciplines listed here have been dramatically changed by the introduction of the computer. It's important to CS majors and non-CS majors. Many students enter a course like this, specifically this course, and learn that they really love programming. So I never wrote a program before college. I was not a high school programmer. I didn't really like computers. I used them, but I didn't want to program. I had no interest in it. Then I had to, for my major, had a basic computing requirement, joined the course, and loved it. It was tons of fun. So it's likely that some of you will develop a love for programming just because of the puzzle-solving, problem-solving precision that is computer programming. On the other hand, many of you may learn that you're not quite cut out for computer science, and that's okay. If it's not your cup of tea, if it's not something you like, and that may not be because you did poorly in the course. You may do very well in this course, but just not enjoy it. The point is, this course should be telling to you about whether or not a degree in computer science and a job in computer science is the right path for you. So be sensitive to that, be open to it, be open to that feedback about yourself. Now's a good time to discuss whether or not CS1101 is the appropriate course for you personally to take. If any of these situations match you, then CS1101 is likely the appropriate course. If you're majoring or minoring in computer science, then this course is for you. If you are attempting to get the scientific computing minor, the course is for you. If you want to learn Java, the course is for you. In general, if you're interested in creative thinking and problem solving, then this course or another course like it, which we'll discuss in a moment, could be appropriate for you. If you intend to take CS1101 or any other advanced course in CS, then this course is for you. However, there may be other options that are better fits for some of you. So if you're interested in learning MATLAB programming language rather than Java, MATLAB is great for engineering. It's used in EE and mechanical engineering, civil engineering, most engineerings, but specifically those three it's very heavy in. Then CS1103 might be a good choice for you. This also would satisfy the general computing requirement for the School of Engineering. So if you'd rather take CS1103, that's a good option to learn MATLAB and still satisfy the general computing requirement. It has a higher number than CS1101, but that doesn't make a course harder. The number is higher simply because it came into existence later. A similar statement can be made about CS1104. 1104 came into existence later and therefore has a higher number, but isn't any harder than 1101. The difference in CS1101 and CS1104 is 1104 uses the Python programming language rather than Java. So if you'd rather learn Python, there is also a CS1104 section available this summer. If that's interesting to you, then that might be the right course for you to take. For those of you that decide to stick in this course and that it is the right course for you, welcome to CS1101. I look forward to getting to know each of you and helping you all learn Java and introducing you to computer science.